let's start probability with the simplest possible example, rolling a die. So the question is, what is the probability of rolling, for example, an even number, right? What are the chances that when you roll a die, you'll get an even number? So before we answer this, we need some language to be able to talk about the problem. So we need to describe what an experiment is, what are all the possible outcomes, and which are the outcomes we care about. So this example will lead us to some basic vocabulary of probability. So an experiment is any action that can produce different outcomes. So for example, rolling a die, like what we were looking at, is an example of an experiment. Flipping a coin, drawing a card from a deck, these are all experiments. Then we have something called the sample space, which is the set of all possible outcomes. So for example, for the one die, the sample space, this big omega here, is just going to be the possible outcomes of the die. So 1, 2, 3, 4, 5, and 6. And then an event is a subset of this sample space. It is the set of outcomes that we are interested in. So when we were asking about rolling an even number, that is a subset of all the possibilities. So it's the even possibilities out of all the possibilities, right? And so the point is that probability is assigned to events, not just individual outcomes. So we can ask for the probability of rolling a 2, but we can also ask for the probability of rolling something even or something bigger than 4 or something in any subset of the sample space. So for now, let's suppose that the die is fair. And so what we mean by that is that each outcome is equally likely. And since there are 6 outcomes, so we're saying that each individual, so each outcome, we're going to say has probability 1 over 6, because they're all the same. So there are 6 outcomes. Chance of getting any of them will be 1 in 6. And what we are interested in is the set or the event 2, 4, and 6. And so to find this probability, we essentially add up the probabilities of each one. So what we'll see when we write this out will be that the probability of A is just going to be the probability of 2 plus the probability, so here of the set 2, plus the probability of the set 4, plus the probability of the set 6. And since each one of these is going to be 1 over 6, we're going to get 1 over 6 plus 1 over 6 plus 1 over 6, which is just 3 over 6, which is half, right? So in this particular case of a fair die, the probability that you get an even number is half. Okay. But let's formalize this a bit more. So what is probability, right? So a probability measure is a function. So it's going to be a function that assigns to. So a probability measure is a function that assigns a number to each event. So the idea is that every time you have an event, you have a probability, and it satisfies 3 basic rules. So first, that the probability of every event is always a number between 0 and 1. Second, the probability of the whole sample space is always equal to 1. And so something in the sample space has to happen. So if the probability of everything has to be equal to 1. And third, if events do not overlap, so if you have a series of events and they are disjoint, so they do not overlap, then the probability that one of these events happens, so their union, so like the OR of these events, is going to be just the sum of the probabilities. And this is what we used in the example before. The outcomes 2, 4, and 6 were disjoint, so we just added the probabilities. And so intuitively, probability measures how often we expect an event to happen if we repeat the experiment many times, right? And so that's the frequentist interpretation of it. And so it's this idea that if we were to do the experiment many, many, many times, we would expect to see it behave like the probability, right? If you were to throw a fair die many, 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 many times, we would expect that the proportion of times that we see the number 1 would be 1/6.